Okay. So in cluster computing, as I said, it is a type of parallel distributed computing, and in which you can see the nodes participating in the cluster, they should have similar architecture, right? If you consider 30 computer system, all the 30 computer system must be of same characteristics, behavior, or same architecture. Okay, so each machine is called as your standalone machine, but we need to collect one or more machines, or typically we go for hundreds of machines to form a cluster. Some of the key components of cluster is, you can see personal computer is can also participate in the cluster, workstation can participate, server can participate, or SMP can participate. So SMP stands for symmetric multiprocessors. Okay, so they can part of your cluster. So clusters are generally made to make a realization of single system image. Single system image means, suppose a user is interacting with a system. Okay, let's say that is cluster manager, and behind cluster manager, if there are 1,000 machines are there, right, which is coordinated by the cluster manager. The user is connecting with the cluster manager. Cluster manager, once it receives the application, it divides the application into small part and execute in individual machines. And once it is computed, individual machine computed the assigned task, so they will return the result to again cluster manager. So cluster manager role is to partition the task. Cluster manager role is also to aggregate the task. Both are done by cluster manager, and cluster manager finally return the result to the user. So for user perspective, if we see, user is only interacting with whom? Cluster manager. User is not interacting with individual machines. That's why the whole system is treated as a single system image. So user feels that, or it is an illusion to the user that whole system is treated as a single system. And as a user also, user may not understand what is the complexity of the environment, what is the middleware. User may not understand. That's why this system makes it possible to make everything as a virtual organization and treat everything as a single system. So clusters are usually deployed to improve speed and reliability. Reliability can be achieved if we go for redundancy. Even if I have 30 machines and I need 15 machines, I can create the replica. 15 machines replica. So for each machine, let's say I have one replica. So together we have 30 machines, but actually we need 15 machines, so that we can achieve the reliability of the system. Again, reliability can be done in a series way or parallel way. Series way means if a particular component is failed, it is going to impact subsequent component. Just like we have 8 semester, you can consider each semester as a module. So if you have an impact in the first semester, it is going to impact the second and so up to last semester, right? So similarly, we have connecting in single case, in order to calculate the reliability of a particular component, you should see the reliability of the previous components. Okay, because we depend on that. But when you go for parallel system, they are working simultaneously. So reliability of a system is not dependent on the previous systems, right? In that way, you can calculate reliability of a particular cluster. So similarly, in a typical cluster, what we have? We have network. So generally, we use cluster means we can consider a local area network where we can set up the cluster. So it is much more faster than any other computing paradigm. Latency also very low, right? If it is a parallel system, latency is very low. If it is a distributed system, latency is more compared to the parallel system, right? So we use a low latency communication protocol. The protocol name is called as MIRINET. MIRINET. That is a very lightweight protocol that is used in the case of cluster. And in cluster is a tightly coupled system. It is not a loosely coupled system. But in comparison to symmetric multiprocessor, if you see, it is loosely coupled. But actually, it is a tightly coupled system. Okay. So there are different types of clusters are there. One is called as high availability cluster. So we want to achieve availability 24/7. Like if we go for Amazon, Amazon shows availability is 99.99. The availability till now it achieved by Amazon is 99 followed by 9 nines. So total 11 nines are there. So adding an extra 9 in the right part and after decimal part is very, very difficult, right? So day by day, they want to increase the redundancy or to achieve a good availability, they are making redundant system. High availability also called as failover cluster. Failover cluster means if a system is failed, without any interruption, another server is going to work for that. Just like primary secondary concept. If primary is failed, secondary has all information of primary. So it will immediately start. Right? Similarly, we have another type of cluster that is called as load balancing cluster. So load balancing cluster's responsibility is to divide the work among all the machines equally. Not only in terms of number of tasks, but also in terms of equal load. Okay, I told you in previous lecture also. Suppose I am distributing two work to everyone, and one person is requires 2 hours to solve two tasks. On the other hand, another person requires 2 minutes to solve the task, and that is not good. That is not a load balance system. Load balance means you have to see equally distributed and equally load should be distributed, not based on the number of tasks. Similarly, another type of cluster is there, that is parallel and distributed processing cluster. So you can see an example here. So we have a set of nodes here, starting from node 1, node 2 up to node n. Another set of cluster which is having node 1, node 2 up to node n. Okay, so you can consider this is a cluster, this is another cluster. So one cluster may be connected to another cluster through switch. And then also we are using switch, right, to connect from one system to another system. Okay. So where is load balancer? Load balancer may be present here, right? Which is control, load balancer can control this switch. So load balancer has a idea about load balancer has the idea that how much work is assigned to cluster 1 and how much work is assigned to cluster 2. So somebody has to coordinate, right? So if it feels that no, cluster 1 is overloaded, then it will redirect all the requests to cluster 2. Okay. So in this way, load balancer is coordinating all the nodes. So these are the components we have: cluster nodes and communicating with each node, that is cluster network, and several types of characterization is required. Right. Now some of the operational benefits of clustering. First one is system availability. Okay, availability you can calculate based on a formula that is called as uptime and downtime. For example, out of 24 hours, if you take an example of our IRCTC site, IRCTC site is down from night 11:30 to 12:30, let's say 1 hour. So that is a maintenance time, right? So out of 24 hours, 1 hour the site is not available. So if I consider that 1 hour is downtime, uptime is 23 hours, right? So availability can be calculated as 1 minus downtime by uptime. So 1 minus downtime means 1 hour divided by 23 hours, right? So you will get availability. Obviously, higher availability is always required, right? So similarly, we have studied something called as RAID, right? Redundant array independent disks or inexpensive disks, right? RAID is also having several levels: level 0, level 1, level 2, level 3. Why RAID is used? To avoid fault tolerance. To avoid fault. If any fault is there in the system, in order to avoid that, you need redundancy, right? RAID supports that one. So hardware fault tolerance is also one of the key benefits of clustering. So you can achieve, even if there is a failure, you can achieve the desired performance using cluster. Similarly, if you look at OS and application reliability, we can run multiple copies of the operating system application through this redundancy. So there is a concept called as multi-tenancy. Multi-tenancy means same piece of software if you give it to multiple users. Right? In a server, let's say we have purchased a Windows license, right? Or Linux license. Okay, Windows license or Linux license. Let's say 30 users can log in at the same time. Okay. Simultaneously 30 users can access, right, from a particular lab. So there, what you have there, you have multiple copies, right? Whenever first system is on, that will be given one copy. Like that, at a time, if you have 30 licenses, we can go for 30 different systems. Right. So reliability can be achieved, right? Application reliability is there. Multi-tenancy also. I told you about multi-tenancy. Multi-tenancy means Same piece of hardware, same piece of software is given to multiple clients. So they can use that one at a time. So that is also one of the feature which is taken by cloud from cluster computing. Okay, scalability is there. Today you have 100 system, you can increase to any number of system based on your capability. Okay, suppose I want to connect all the cluster. I assume that each hostel is a cluster, and I want to connect all the hostels into a particular network. So you can form different type of cluster and you can execute it. Okay, similarly, high performance is achieved. One of the important part here is there is a difference between HPC and HTC, which is also identified by Professor Rao. Okay, so there is two difference: HPC and HTC. HTC stands for high throughput computing. We are talking about HPC, that is high performance computing. Both are not same. Cloud always focus on high throughput computing, but these clusters achieve high performance computing. What is the difference? For example, same piece of work, right? For example, you have written a code, but you want to pass different data, right? Suppose addition of two number program you have written, and you want to execute the same program in different computers or different cores, but with different data. Same program, but input is different, right? So you can go for high performance computing. Okay, but high throughput computing says that what you want to achieve, how many tasks you can complete within a deadline. Based on that, throughput computing is there. HPC case there is no deadline, right? Throughput case there is a strictly deadline. Throughput means what? How many works you can do within a time duration, per second, per minute, per hour, per day, whatever may be the time. You have to be target oriented. HPC primarily focus on the achieve what we can achieve after a particular time duration. So cloud primarily focus on high throughput computing. Again, yes, HTC also you need HPC, right? Like distributed computing case also you need parallel computing. That's why parallel computing is a subset of distributed computing. So HPC is a part of HTC, but HTC objective is different, right? Okay. Next, there is a computing invented in 1990 by one of the scientists. His name is E.L. Foster. He presented a paper at a conference related to grid. The concept is of grid computing is not new, right? Because you know about electric grid. If you visited some dam, okay, in India, you have seen there is a grid, electric grid. In also Microsoft Word, also if you go, there is something written as grid lines. So if you click it, it is putting some lines, just like a table, right? So grid concept came from that one. What is the objective of grid? How it is different from cluster? Cluster case, you are aggregating homogeneous computer. Homogeneous means similar architecture. Okay, similar behavior computer system. But if you go for a higher number, suppose I need 10,000 machines of same architecture, practically it is not possible. If I say in our campus, I need 10,000 computers with same configurations. It is not practically possible. So when you want to aggregate a different type of machines, that is called as heterogeneous machines. Earlier machines are homogeneous, but now machines are heterogeneous. In heterogeneous case, you have to go for grid computing, right? And the main work of grid is to aggregate the resources like cluster and share the resources, and many maximum scientific engineering applications are running under grid. Like I mentioned about BOINC, if you install in your system, that is a part of grid computing, not cluster computing, grid computing. Okay, now let us compare with electric grid with power grid. In electric grid, what happened? In our home, we have sockets, like here sockets are there, right? So simply you are connecting your charger and charge it. You don't know where electricity is coming. Okay, you have a pole outside, but from if I ask where the electricity is coming from to that particular pole, we don't have answer. Which power grid we have connected, there is no answer, right? So when you compare electric grid with the grid, there we are talking about electricity, here we are talking about computation, or we are talking about storage, we are talking about network, we are talking about bandwidth. Okay, that is a terminology is changed, but overall the concept is same. So we are not aware of that where and how the electricity is generated, but it is coming from power grid, but where the power grid is located, we don't know. Simply we charge our laptop or we run our air condition, whatever maybe we pay the bill, right? In grid case also, we get these things: processor, storage, data, and application. Okay, we need processor, storage, data, and application without any knowledge where it is stored. Right? Where these storages are coming, I don't know. Right? I don't have any idea that where is the source, right? Whether it is coming from Mumbai server or it is coming from Japan, we don't have any idea. Take this. Okay. So what we are doing in our grid we have these are the resources, right? Processor, storage, and applications. But where it is running, we don't have any idea, right? This is a very little knowledge we have. Like if you go for Amazon, Amazon has two data centers in our country. One is at Mumbai, another is at Hyderabad, right? So whenever you use some kind of virtual machines or you need a server or you need a HPC server, you can make a request to Amazon, right? Our zone is called AP South Zone. AP means Asia Pacific South Zone. In that zone, we have Mumbai server and Hyderabad server. So our nearest point is Hyderabad. So in order to minimize the latency, we will locate to Hyderabad center. Okay, that you can do in Amazon. Okay, what are the components like cluster? Here, personal computer is also a component of grid. Workstation can participate in the grid. Smartphone can be participate in the grid. Any device having computation and storage, they can participate in the grid. Now, when we use grid computing, we need grid computing when you need massive power, like COVID time. If you look into drug development, right? Although some sequence is coming, they are trying to execute it, right? There are no so many sequences are there. So finding an appropriate sequence, or genome sequence, or bioinformatics application, you need grid computing. Because you cannot afford 100 machines cost, right? You can go for 2 GB to 4 GB or 8 GB. But if you need 800 GB, what you will do? You have to go for these computing paradigms like grid or cloud or any other paradigm, right? Okay, so many institutes, many organizations, they have contributed to the grid computing project. When an individual is not capable to solve a particular problem, they have to depend on the grid. Okay. Now, you see here, what are the applications? The main application is if you need a computer simulation and modeling. If you need a execute your application, suppose your application will run for 10 days. Okay, in that case, you have to go for grid computing type of paradigm because it is not possible for an individual machine to run it, right? When you need number of cores is very high, in that case also you will go for grid computing paradigm. Most the scientific engineering applications, like I mentioned, weather forecasting to know the temperature of a particular place or whether there is a rain in a particular place or not. These all are running under the grid computing paradigm, right? They all are these all projects are taking resources from the grid computing. Okay, but or you can say if you go for astronomy, like if you see Chandrayaan 3, right? Repeatedly you are getting images, and if you see the size of image, it is not small. These very high quality images, right? You can zoom into any level. But whenever we are taking picture in our phone, when we zoom it, we are getting blur, right? So data visualization purpose also you need grid computing. Right? Not only processing is important, but also storing also you need computing, right? We need some storage that also will be provided by the grid computing. Okay, like that other there through grid computing you can utilize the resources. Otherwise, the resources are underutilized. So if you take the same resources to multiple people, definitely the resource utilization is going to be improved. Okay, now these are some of the applications like crystallography. So crystallography is experimental science for determining the arrangement of atoms in a crystal solids. So biology applications, gravitational physics application, earthquake application, lot many applications you can find from the grid. But the problem is that in grid computing, nobody thought about the business model. Right, as I mentioned earlier. Only in clouds onwards, people are thinking about the business model. These are all are voluntary projects that are running under GRADE. Similarly, detection and modeling of natural disaster. Okay, reactor application, physics application, weather forecasting. I told you, all are part of this BOINC project. Okay, and they are taking the resources, but they don't own a single resource. University Berkeley, except their infrastructure, they don't take any other resources. All the resources are voluntary only. You can also join and you can also share your resources with the BYNC platform. Now there are different types of grids are there. So these are the different types of grids. Computational grid means if you want to execute compute intensive tasks, then you will go for computational grid, where computation is more important than any other. Okay, there you can go for computational grid. Similarly, you can go for data grid, where data is more important. Like we have seen, Facebook is having more data rather than computation. Or I told you LSC, large hadron, right? Hadron something, right? Collider. That is a project which is a part of data grid. Next grid is called collaboration grid. So if multiple organizations are participating and executing an application, that is called collaboration, right? Like I told you, 3 organizations is there. Let's say these organizations are having 10, 20, and 30 number of servers. But if you need 35, so individually they are incapable. Right or not? 10, 20, 30, if our requirement is 35. So individually they are not capable. But one organization can be collaborate with another organization to run that particular project. Right? That type of collaboration comes under this collaboration grid. Right? Mostly government funded projects or any project which is executed by 2 different organizations, they use collaboration grid. Similarly, network grid, where communication is more important, not computation. Okay, network means you have to focus on bandwidth, right? How faster you can communicate from one unit to another unit. So there are various communication protocols are there that is used in for network. The last one is utility grid. Utility means based on your usage you have to pay, right? You have a grid setup. If a user initiates a particular application and using that application for 3 hours. So let's say per hour whatever cost is there, you have to multiply with 3, and that user has to pay for that, pay for using that resources. So more or less, actually, overall we call there are 2 types of grid only. One is computation and another is data. All other are called as hybrid type of grid. Yeah, there are 3 parts in grid component. One is the user, another is group, another is site. One view is user view. What user want? User wants single system image. User will connect to only one system, and that system may connect with 1000 systems, but finally the result will be written by that system. That is user perspective. Group means you can form different type of clusters or different type of users you can put in a particular group. Different resources also you can put in a group, right? Like something called as URI, Uniform Resource Identifier. If you go for Amazon, you can find something called URI, Uniform Resource Identifier. This is used to locate a particular resource. Suppose your resource is present in a particular IP, that will be given by your URL. Okay, not URL. URL is a website. Suppose you are using. URI is to locate the particular resources. So they all are coming under groups. So whether one person can participate in a group, it depends upon its membership. So if there is a public group, anybody can participate. If there is a private group, it is either invitation only, or a member can be added in a private group by taking the consent of all the members of the group. Right? So it is based on the membership. Another sites we have sites. What are the sites we have? We have heterogeneous resources in the case of grid. Right? System is completely heterogeneous, right? They may use different protocols, they may use different architecture, they have different computational capability. So everybody will require, these components are required to form a grid. Now the last type of computing is called as utility computing before cloud computing, right? So cloud computing is a real example of a utility computing. I told you water is a utility, electricity is a utility, gas is a utility, and telephone is a utility. The fifth utility system in human cycle, that is called as computing, right? So there are many models are there. If you go for service provisioning model, service is provided based on some charge, right? Like if you take our mobile providers, early days mobile providers are charging per minute basis. Okay, so if you talk for 1 second, you will pay. If you talk for 59 seconds also, you will pay the same amount. Okay. At a point of time, all mobile providers switch to second plan, right? Based upon the number of seconds, you will be charged, right? That is another type of pricing schemes. Third type of pricing scheme nowadays, what we are doing? We are going for subscription based. Subscription based means you are paying 719 rupees for 84 days, okay, or 749 rupees for 90 days, and you subscribe for a particular period. Okay, every day there is a KP is there. Okay, so that is a subscription based. Another case you can say you pay as you go. Suppose you are subscribed to a particular plan, like electricity, if you look up to 100 units, the cost is same. If you use 1 unit, the cost is suppose X rupees. 100 unit also you will pay X rupees. But once you exceed 100, one band you are exceeding. So the cost is again increasing. Right? 0 to 100 units, let's say 1 rupees. 101 units onwards, let's say you are paying 2 rupees up to 200. So there are different tier is there. Right? Based upon your usage, you are going to pay for it. So you may get a service in flat rate, or you can get with a subscription based, or you can go for pay as you go. There are different type of pricing models available in the utility computing paradigm. But there is no need of any infrastructure or no need of any cost in order to start a particular service. That is called as no upfront commitment. There is no commitment. You can create an account in utility computing. You can use the resources. Once you release the resources, the amount is charged. Like if you create an account in Amazon, and if you want to use their service for 2 hours, after 2 hours, when you release the resources, the bill is calculated. Bill is not calculated before you start the resources. That is called as no upfront commitment. There is no commitment. Okay, you can simply use the services. After that, you can pay. That's why it says that there is no cost, or even if there is a cost, that is very nominal cost. Okay, I also told you about pay per use. When your demand is fluctuating, your demand, you cannot predict the demand. Like if you take an example, if you remember the Big Billion Day, first Big Billion Day by Flipkart. Okay, first Big Billion Day, if you remember, Flipkart site is crashed. Okay, because suppose assume that normal traffic is 1 lakh, right? So they expect that today is Big Billion Day, so maximum user we can reach is 5 lakh. But actually the number of users visited to Flipkart is quite more than their expectation. Obviously, network means maximum limit you have. Like LEDs, if you see IRCTC also, the site is very slow. Now they have increased the size, right? So definitely more user will get, but once you exceed that one, you will not get service. Unless a person is locked out, you cannot enter to the system, right? So when your demand is not clear, in that case, it is better to go for pay for use mode. Okay, and my demand is not clear whether I need 10 server or 1000 server. I am not sure about it. So go for pay for use mode. Okay, so here you can see, like nowadays, if you look into water also it is comes with a meter, right? If you see Warangal, it is instant, right? So even if there is a drop of water is coming, so the meter is running, right? Water is also with respect to the meter. If you exceed the meter, you have to pay bill like electricity meter. Similarly, if you look into other factors like gas also, if you go to phone pay also, in the front page, you can see there is a piped gas. Many metro cities are now available with piped gas. So based on your usage, you have to pay. No need to carry the cylinder, right? So that is also an example of the utility computing. So the main idea of going for utility computing is to improve the resource utilization. Okay, resource utilization is quite poor in the previous cases. So in this case, we want to enhance the resource utilization. That's why we are going for utility computing. Now you can see consumer and provider. Consumer has certain requirement. Provider is having some surplus requirement. Right? Somebody is having more resources, then only he or she can provide you. So suppose consumer is asking, I need to purchase service. but where to purchase? I need, let's say, 4 virtual CPUs. Where I will get? So provider on the other hand saying, I have some infrastructure and that infrastructure is a surplus infrastructure, so I provide it. Right? So both the customer and provider meeting at a point that is called as marketplace. They will go to DMart or we go to Reliance to purchase the things. We have some requirement and they have that item to sell. Right? So we are meeting in a place that is called as marketplace. But in this computing paradigm, this is a virtual space. It is not an actual space like our shopping malls. Right? So what are the factors you will see that is written here? This is the customer requirement. Like service should be guaranteed. Who will ask? Customer will definitely ask. Suppose you purchase a refrigerator. What you are asking? What about warranty? What about guarantee? This is service assurance. Similarly, availability you can ask, contractor management you can ask, consultant you can ask. Suppose you hire a web service or you purchase a server online, right? VCPU, virtual CPU and virtual server or virtual GPU. So you will ask if something goes wrong, to whom we have to contact, whether customer care service is there or not, right or not. So this type of request will be made by whom? User perspective. But if you look in the provider perspective, provider is responsible for maintenance. Okay, for example, today we have Windows 11, okay, or Windows 10 or Windows 11. Let's say Windows 15 released after 10 years. Who is responsible to install the updated Windows? Provider. As a customer, you will simply say a provider. All providers are giving Windows 15. Why you are not giving Windows 15? So provider responsibility is to install the server, install the operating system. Everything is done in the provider end. As a customer, I will pay. Let's say I am paying, let's say, $10 previously. Now I am ready to pay $12. Right? So these are the set of requirements from the provider perspective. So in order to meet this consumer and provider, you have to go for some kind of agreement. So one of the popular agreement we do in cloud, that is called a service level agreement. So service level agreement is same as our warranty card or a guarantee card, right? If you purchase something, some product, refrigerator or air conditioner, if it is not working, what you will do? You will go for a guarantee card or guarantee card. Okay, if your provider says that no, we will not provide service, then you will go to consumer court, right? So consumer court will see what is the terms and condition you agreed why you purchase that particular item. So similarly, in the cloud case, we have a formal agreement that is called a service level agreement between consumer and provider. Okay, they agree to certain terms and conditions. That is SL. So there are many researchers, they are working in SLA standardization. Currently also we are a part of Bureau of Indian Standard. We have studied in Harvard BIS. So we 3 faculty members are now member of BIS. BIS is actually preparing various standards. Okay, we belong to cloud service law. So whatever document they are formalizing in government perspective, it will be reviewed by this particular team. But the problem is that who is preparing this warranty card or a guarantee card? Customer or provider? To purchase a particular item, who is preparing the terms and conditions? Provider. The customer needs to bother about these terms and conditions. If you read terms and conditions, you cannot install a software. You cannot purchase a thing also, right or not? So SLA standardization is more important because it is one side. No? Provider will write condition in small letter or I write condition applied, and you agree to the terms condition. So they have not taken opinion of the customer also, and customer also not aware of the thing. Whenever we purchase the thing, we don't know about compressor and other things, right? So SLA standardization is more important. That's why European countries, especially, they focus on how to standardize the SLA. Because SLA, whatever terms condition used by one company, it is different from other company. All companies not following same one, right? Some companies offering you 3 years, some companies offering you 1 year, some companies offering 6 months only. Right? There are different type of policies out there. Okay, similarly, we have different pricing scheme. We have to agree on a particular pricing scheme. Whether we go for flat one or we go for pay you go, that you have to decide. Similarly, other factors also you can see. Yes, these are the different pricing schemes we have. Flat rate means, let's say you pay like mobile, you recharge, let's say 200 rupees, unlimited call, unlimited internet for 1 day. That is a flat rate. Okay, unlimited service is called as flat rate. And this tier means 1 to 100 unit, this much. 101 to 200 unit, this much. 200 unit to 300, this much. When you exceed a particular tier, then you have to pay more. Similarly, subscription, I have subscribed it to for let's say 30 days, like our 84 days plan. That is a subscription base. We have subscribed, per day we have a quota, we have to, we should not cross that particular quota. Right? Similarly, another is metered. Metered means you will come with some unit, let's say 230 units, per unit is let's say X rupees, so you have to pay 230 X rupees at the end of the day. That is another pricing schemes. And this pay as you go model, another standing charge. So not many pricing models are there. So basically, in the pricing model, there is two type of prices there. One is called a static price, another is called a dynamic price. Static price is compulsory, dynamic price is random. For example, if you see our premium Tatkal scheme, in premium Tatkal scheme, you are paying the base charge plus Tatkal charge plus dynamic price. Three components are there. Okay, first two components are static, right? For example, XCT to ICT, the price is already fixed based on your coach, right? That is fixed. Tatkal charge is also fixed, that is not variable. This premium part, okay, dynamic part, that is very with respect to how many customers are visiting the site, what is the day, whether it is a vacation time or not. Based on that, that factor is decided. Okay, for example, demand is more, definitely the cost is more. Right? Demand is less, the cost is less. Right? Based on that, the dynamic factor is designed. So you can also design a pricing scheme. Like recently, I studied the algorithm given in the outer ring road. All of you know about ORR, right? Hyderabad. You have outer ring road. Can you guess how that the cost is calculated in outer ring road? How they calculate ORR? Whenever a vehicle is entering, some gate is there, right? So it is recording your timestamp. When you exit from the ORR, again there is a gate is there. That is recording your timestamp. How the cost is calculated? What may be the parameter? Can you guess what is the parameter? Obviously, one parameter is kilometer. What is the distance? Right? Time of the travel. Now they are very clever. Suppose you entered from one location and you exit from another location. Let's say the distance is 10 kilometers. Okay. So maximum speed is 120 kilometers. Our ORR speed is recently changed from 100 to 120 kilometers, the maximum speed. So to travel this 10 kilometers, if you calculate at a speed of 120 kilometers, you will get a time. Right? You can get a time. Let's say the time is X. But you travel less than X time. What it indicates? It is overspeed. Automatically you will get a fine. There is no need to put a camera. Right? Cameras are also installed in between, right? But it is easy to calculate. If somebody is traveling at 140, he will definitely exit in faster way, right? So you can charge the fine. Similarly, somebody is moving very slow. Like if you go for Dubai-like country, they have a restriction. The speed limit should not be below 40 kilometers or 60 kilometers. There also you charge the fine. So not only that distance is a factor, other factors also you need to consider in order to charge it. Like what is my proposal related to this ORR? So we discussed with Professor Radhakrishna also while we travel to Warangal. So suppose maintenance charge of ORR also need to be concerned, right? Like if you see IRCTC ticket, in Indian Railway it is clearly mentioned, Indian Railway recovers only 57% of the cost. You go to any ticket, in the below it is written, only they are able to get only 57%. That means government is running the minus 43%, right? 43% is maybe given by government. 57 is we recover from the customers. Similarly, overall also maintenance charge is there. They are putting flowers in between and a lot of things are doing. So ultimately, what you have to do? You have to recover that particular cost. So while you are designing this pricing scheme, not only these factors are important, but also the maintenance fee, everything you need to assess. For example, yearly maintenance charge is 100 crore. Assume that 100 crore. So you have to see that how many vehicles are moving. In average, you have to design a machine learning model so that your revenue should be greater than 100 crore. Then only government will not pay any amount, right? So different pricing schemes also you can design. A lot of scope is there in cloud to do it. Okay. Okay. There are set of Risks are also related to any type of computing paradigm. Backup is always an issue. Security, privacy, trust, reputation. Risk is always there for if you go for outside your premises, right? Yes, if you maintain your own infrastructure, then you are boss of your infrastructure. So you can put any type of policy. But when you go beyond your scope, then we don't know what is our data, whether it is secure or not, that we don't know. Right? So there are several risks associated with utility computing. Now come to the last computing. That's I say initially there is high performance. Now cloud computing. Right? What cloud says? So there are many researchers and many organizations have given the definition to the cloud. One of the organization is National Institute of Standard Technology, US. So they have given this definition. What it says, cloud computing is a model for enabling ubiquitous. Ubiquitous means you can access to their resources anywhere in the world. Anytime, anywhere, you can access to the services provided by cloud. Convenient, on-demand network access. At any point of time, you can access. There is no issue. Only you have to ensure that internet connection is there. Without internet connection, it is not possible to get any kind of services from the cloud. So there is a shared pool of configuring computing resources. There is a pool of resources. Like I took an example of swimming pool. If you go for swimming pool, you have a plenty of water, right? So from that water, whatever your requirement is there, that is just like a cup of water. Like if you go to data center, in a data center, you have so many servers, around 50,000 to 80,000 server is there. In that 80,000 server, if I'm asking only one server, so it is simply a cup of water from a swimming pool. So like that, we have a shared pool of configuring computing resources. It may be storage, it may be computation, it may be any application or services. From there, you will given some resources. So your limit should not be, your limit never be exceed than the pool. Whatever resources are available in the pool, your requirement will never exceed that one. A simple example you can take. Like if you see a small child, the child can count 0 to 9. So if you say 100, 100 is infinite for that child. The child can only count 0 to 9, not beyond that one. So 100 is the maximum limit. Suppose you need a maximum of 10 lakh rupees. So if I say 1 crore is infinite for you. Similarly, this pool of resources will never exhaust it. Because they are expanding the infrastructure in such a manner that they are by looking into day by day, people are moving to the cloud. They put a very large amount of infrastructure, so they never exceed this particular infrastructure. And you can request for the resources, and similarly, you can release the resources also. Not only you are requesting the resources, once your job is done, you have to release the resources also. Right? Now, here also you can see the similar type of situation which I showed you earlier. One side customer is there, another side provider is there. What the first customer says, customer says, I need to grow my infrastructure, but I don't know how long. Suppose you start a company, right? You don't know what is the sustainability of your company. Whether your company will run or not, also you don't have any idea. Right? You don't have any idea. So initially you cannot purchase a server to host your applications or to run your website. You don't have any idea, right? So this customer says that I need infrastructure, but I don't know what is the duration. If you are sure about objective, you can purchase your infrastructure. But this customer, if you see the provider end, one provider is saying, I have lot of infrastructure and I want to provide it. Okay, somebody is having surplus, somebody is requesting the resources. So they will meet in cloud in the market. Similarly, this customer is saying, I cannot invest in infrastructure. I just started my business. I cannot pay because initial cost of a startup company is very less. So they cannot afford an infrastructure, right? If you see provider end, this provider is saying, I have a surplus of infrastructure that I want to make rent or make use of that particular resource. So they meet in a global cloud marketplace and they sign in a service level agreement and they can get the services. Okay, now coming to different type of clouds. So cloud is divided into different types based on certain characteristics. First characteristics is called as deployment. Based on deployment, you can divide. Deployment means where the cloud is located. Cloud is located inside a premise or outside a premise. Based on that, you can categorize the cloud. So first type is called as public cloud. Public cloud is meant for public purpose. Anybody can use that particular cloud. Like Google is providing Gmail service, Google is providing Google Map, Google Photos, lot many services. That is common to everyone. That's why that is called as a public cloud. Okay, public cloud always for meant for public, common people only. Next is private cloud. Private cloud is restricted to a particular organization. Like if you want to set up a cloud in our institute, so it is restricted to NIT Warangal only. Only NIT Warangal stakeholder can use it. Anybody is outside NIT Warangal, they cannot access our resources. Okay, so that type of cloud is called as private cloud. Like if you see our email system, like every institute is providing their email ID, right? Like at nitw.ac.in, like NIT, let's say raipur.ac.in. Different type of institutes are providing different email IDs. So these email IDs are admin is from that organization, but maintained by whom? Maintained by Google only, right? Gmail and our institute email both are same. Only thing is that it is maintained, both are maintained by Google, but Gmail ID is for NITW, it is powered by NIT Warangal. But everything is done by Google only. So that is called as a private cloud. So private cloud can be on-premises if you set up your inside your organization. Like any days, people are using their own email system. Like if you go to NIT Warangal, they have their own email system. So that is powered by NIT Warangal, hosted by Warangal, maintained by Warangal, maintained by Warangal only. So that is called as on-premises private cloud. Within that organization, it is there. Off-premises means somebody else is maintaining. Like Google is maintaining on behalf of NIT Warangal, right? So that type of cloud is called as private cloud. Another cloud is called as community cloud. Community cloud is similar to the collaboration grid. Like if you see a multinational company, every company is having multiple branches in India, right? One may be at Delhi, another may be at Mumbai, another may be at Kolkata, another may be at Hyderabad. So in order to develop a particular software, one unit is better in development, while another unit may be better in maintenance, another unit may be best in testing, lot many. So everybody's contribution is required to make the software successful, right? So there they can use the community cloud. Right? When one or more organization or one or more center wants to develop something, they can go for community cloud. And any combination of these clouds can be considered hybrid cloud. So like private cloud, community cloud can also be hosted within premises or outside the premises. So as more organizations are associated with community cloud, one of the organizations can take lead and can set up the things, and other organization can use that particular cloud. Okay, or it may be completely outsourced. Although multiple organizations are there, they are not maintaining. Somebody else, third party, is maintaining that one. So it may be within campus and without campus. However, if you look into the service perspective, the cloud is divided into infrastructure as a service, platform as a service, software as a service, and last one is called as XaaS. That is called as anything is a service or everything is a service, right? So infrastructure as a service case, we need computation, storage. Generally, we create a virtual machine to deliver computation or storage. That is infrastructure. Platform means you need a runtime environment. Like operating system is a platform. Middleware is also used to make a platform or to hide the internal details. So they are coming under the platform as a service. Last one is software as a service. Web browser can be considered a software as a service. We are using Mozilla Firefox, Google Chrome, Internet Explorer. These all are treated as software as a service. So these are the only three type of prime classification under services. At a later point of time, people have started their own type of services. Like I showed you, one is called as quantum computing as a service. People say sensor as a service, security as a service, healthcare as a service. That's why the term is called as XaaS. Anything is a service or everything is a service. So if you see NIST, as for NIST, NIST says that there is 4 deployment model. 3 service model and 5 service attribute. So that's why it is called as 3-4-5 model. 3 services, 4 deployment models, and 5 characteristics. So you can see service case. I'll show you this diagram so that you can easily understand. See this one. This is recently released. Earlier we have a pizza as a service 1.0. Now recently they released one pizza as a service 2.0. Suppose in your let's say at your home you want to prepare pizza. What you will do? You need ingredients, right? Those things are required to prepare a pizza. Or think about a Maggi, right? You need Maggi packets. You need let's say masalas and other things, right? So you are responsible for everything, right? Preparing pizza, everything you are responsible. But when you go for cloud, you don't want to prepare, let's say, prepare everything. You want to give something to the cloud. Infrastructure. What infrastructure is required? In order to prepare a Maggi, you need Maggi packet, you need masala. So these are called your infrastructure. Okay. So if you are ready with this one, then you can cook at your home, or you can go to your friend's place and cook there. Right. Assume that your friend's place is considered as a cloud. So if you are preparing at your home, then you are not adopting cloud. When you take this Maggi packet and preparing at your home, that can be considered as you are using cloud. Okay. Then what you require? Once infrastructure is given, you need platform. How to prepare Maggi or pizza? You need induction, you need stove, or you need gas connection. Right? Otherwise, it is not possible to prepare the pizza. That is called as platform. Okay. One platform is at least required to prepare the pizza. So platform you can ask to the cloud service provider, or if you have platform, you can go towards it. Okay. And after that, what you need in order to suppose pizza is prepared, right? You have ingredients, you have let's say gas and other things to prepare the pizza. Now pizza is ready. What you need? You need plate, or you need a table. Okay, to serve the pizza, right? That is called as a software as a service, right? So out of these services, some part, let's say you will say I will maintain my own infrastructure, but you provide platform and software as a service. Like our department, we have purchased Anek. There is a software called as Anek. Anek is a Sanskrit word. What is the meaning of Anek? Anek means multiple things. Anek means multiple things, right? This is a Sanskrit word originally, but Hindi also is Anek, right? So Anek is not an infrastructure as a service. It is a platform as a service. So platform they will provide. So who should take care of infrastructure? We have to take care of our own infrastructure. So out of these services, some service you can ask to cloud, some service you can take care of yourself. Similarly to this example, we have infrastructure, platform, and the software as a service. Okay, now coming to different type of service attributes or characteristics. One of the service attributes I already told you, that is called as pool of service, right? That is called as resource pooling. Okay, we have a large pool of resources. From that pool, we can provide resources to our customer. Okay, first characteristics. Second characteristic is that broad network access. Broad network access says that through any device you can connect to the cloud. You can connect through your mobile phone. You can connect to Gmail. From laptop you connect to Gmail. Through supercomputer also you can connect to Gmail. So device is not limited. Any device capable of connecting with internet. So you can use cloud services. One of the cloud services we are using in day-to-day life, that is Gmail. Right? Google Map you are using, that is also a cloud service. Third one is called as measured service. We have seen there are several types of pricing schemes. If somebody is providing services to you, he has to charge you. He or she has to charge you. That is called as measured service. That is called as measured service. You have to measure a service. I am providing services, so I have to take, right? Per hour, let's say the cost is 10 rupees. For example, early days we don't have internet during our BTech time. We don't have internet facility. Individual internet facility was not there. What we do, we go to the internet cap. That internet cap charge us 10 rupees per hour or 15 rupees per hour. So if it is 10, let's say 1 hour, 15 minutes, then you have to pay 20 rupees. How you have calculated? Per hour this much, you have exceeded 1 hour, so it will be considered as another hour. Similarly, when you go for Amazon Web Service, AWS, which is providing virtual resources, once you create an account in Amazon Web Service, you will get 750 hours. Okay, total you will get 750 hours. So how the 750 hours is deducted? If you start a virtual machine, let's say at 2 p.m. and you finish at 2:15, so 15 minutes is minus 1. 750 minus 1. Suppose you started 5 virtual machine. You executed it for, let's say, 2 hours 15 minutes. 2 hours 15 minutes means 3 hours. So 5 into 3, 15 hours will be deducted from 750. Like that, Amazon is providing 750 hours up to 12 months. After 12 months, you will be charged. If you exceed 750 hours, then they will charge you, because when you register for AWS, they will ask you debit card and credit card information. When you register with PhonePe, they are asking you, they are verifying your account, right? They are deducting 2 rupees or 1 rupees when they are returning it. Similarly, whenever you are using AWS, they will check your account information. If your account information is correct or not, in order to check, they will deduct a minimal amount. So that's why when you exceed this free quota, they will directly charge from your account. Right? So you have to be very careful when you use the cloud services. Another is on-demand self-service. Like many places we are going, there is instant self-service. So self-service means you have to pay, you have to go to respective counter, you have to bring plate, you have to eat, you have to put in dustbin, you have to do everything. That is self-service. Cloud case also, everything is self-service. Nobody is going to help you. Right? Everything is maintained by you only. Okay. So, but that is on demand. On demand means whether it is night 2 or day 2 or whatever may be time, any time you can request for cloud resources. Last one is called as rapid elasticity. Rapid elasticity means if you want to expand 10 server to 100 server, it is possible. If you want to shrink 100 server to 1 server, that is also possible. So we have seen rubber band, right? It is elastic. Okay, elastic, right? So you can expand or you can shrink based upon your requirement. Okay, now this is a very interesting slide. When you go for HPC, right? You can achieve HPC through cluster or grid or cloud. So you should know what is the difference between cluster, grid, and cloud. Although I told you some of the differences. Like if you go for service level agreement, in cluster case, there is not that much service level agreement. Or limited service level agreement, you can say. Grid case service level agreement is there. Cloud case of the service level agreement is there. Now, what is the allocation mode? Cluster is centralized or decentralized? Cluster. There is a cluster manager and there is other nodes. So they are centralized. User will connect to one and it will distribute it over other. But if you go for grid, it is decentralized. Okay. Cloud case, you can get centralized, you can get decentralized also. For example, we have so many data centers in the world. If you are pointing to a particular data center, that is centralized. But when one data center can send some task or can migrate a particular application from one place to another place, that is decentralized. Because they are located in different places. So that's why it is called as a distributed system or decentralized. Similarly, resource handling is here centralized, here distributed, here both. The protocols which we have used, that is called as MPI. Initially also we have seen MPI, message passing interface, that is used in the case of cluster. Parallel virtual machine is also PVM, is also a part of cluster. But when you go for grid, GRM is another type of protocol that is called as grid resource and management. This is a protocol that is used in grid. Cloud case, we are using TCP/IP, you know, very popular protocol, transmission control protocol and internet protocol. We have another protocol called as service oriented protocol, SOAP. Okay. That is based on your service oriented architecture. So that protocol is also used. Other protocols, right? Java case also we are using REST protocol, right? Representation and state transfer, the full form. Okay, that is also used in the case of cloud. Similarly, you can distinguish what is the difference between cluster, grid, and cloud. Some other differences you can find here. For example, one of the factor you can see here, security. What is security? Is there any security here? Yeah, security. So cluster case, it is very safe. If it is limited to a particular layer, obviously security is more. But when you open to the world, the security is questionable. So in the cloud case, you are getting no. In grid case, you are getting ah. Means it is not that much secure. It is not fully open also. Okay. Similarly, you can compare the cloud resources with HPC resources. Okay, like I told you, whether to set up your HPC in your organization or to set up or to use cloud for HPC. So you can find from this particular table. Like availability. Availability is on demand, that I told you. Cloud one characteristic is on demand self-service. So any point of time you need any type of server, if you use cloud, you can get it. Suppose you want to run a machine learning application, you need 128 virtual CPUs. It is possible. Okay, whatever your requirement is that is possible in the case of cloud. But if you have in-house infrastructure, it is difficult. Like if you see our department, we have limited number of servers. Let's say we have 10 servers. Suppose my requirement is 100 servers. So we cannot expand 10 to 100, right? So scalability wise, if you go for HPC resources, in-house HPC resources, it is difficult. But when you go for cloud, you can expand to any number, just you have to pay. Okay, again, if there are 10 servers are there, my requirement is 100 server. Even if we purchase another 90 server, what is the sustainability? Do I need that 90 server for rest of the days or not? That also we need to check. But cloud case, what we can do? 10 to 100, I can expand today. Tomorrow my job is over and reduce it 100 to 10. So scalability perspective, cloud resources is better than the HPC resources. Similarly, you can compare other factors also like elasticity. It is dynamic. It is rigid. There is even fixed structure, right? We have fixed infrastructure. Until unless we buy and add, it is not possible to expand our infrastructure. But in the case of cloud, it is very flexible. Based on your requirement, you can expand or you can reduce. Here you can see other factors also. Okay, that's why here also you can see. So you have to make a rough estimate. There are so many interesting problems are there. So you are given with some specifications. Suppose I will tell I need 10 server for a period of 5 years. Maintenance cost is this much. Okay, let's say some manpower cost is this much. I have given two rough estimates. One rough estimate for in-house, another rough estimate for cloud. Let's say period of observation is 5 years. So that is called as the total cost of ownership, TCO. So you have to evaluate both proposals, calculate the cost over a 5 years. After 5 years, what is the cost you have spent for in-house infrastructure and cloud infrastructure? Whichever is economical to you, you can go for it. Okay? That's why I am showing this one. So whenever you compare in-house with outside HPC, you have to look into this. Okay, so there is also a difference between elasticity and scalability. Although these two terms are dictionary wise, both are same. Elasticity case, what we are doing, we can automatically expand or compress. But scalability case, it is a manual. The process is completely manual. And you can see there are different type of scalability we have. For example, I have a system of 2 GB. I am increasing its let's say to 4 GB, right? I am increasing it to 4 GB. So it is a vertical expansion, right? It is a vertical expansion. But when I have one system, but I am increasing into two systems and I am combining them, so I am making it horizontal, right? So similarly, you can see here vertical scalability and this one is horizontal scalability. Nowadays also we go for diagonal scalability by looking both vertical and horizontal. There are many success stories behind cloud, right? Like you can see these examples. One of the example is there is a newspaper that is called as New York Times. So New York Times newspaper earlier it is only in printed version. It is not in electronic version. Nowadays only the newspaper is coming in electronic version, right? So what New York Times decided? They decided that why don't we convert all traditional newspaper into a web-friendly format, so that anybody can choose a particular date and see the newspaper. So what they did, they had scaled everything and they just want to implement it. They hired Amazon EC2 and S3, two services, two popular services. EC2 stands for Elastic Compute Cloud, which provide computational resources. S3 is a storage cloud, simple storage service. So they use Amazon EC2 and S3. Within 36 hours, the web-friendly portal is ready. So that is delivered by Amazon to Amazon is delivered that to the New York Times. So you can browse any type, any their newspaper using that particular portal. So that is one of the success story why we want cloud. There is another company that is called Animoto. Like many occasions, we are taking pictures, right? And later point of time, we convert that pictures into a videos, right? So Animoto does that same thing. Whatever we are doing manually, okay, we choose some online tool or offline tools to do it, right? Animoto is actually doing that work. So Animoto is not having much resources or much budget in the initial days. So they selected AWS. Initially, they taken only 70 servers because they are not sure whether they will run in the market or not. Initially, when you start new to the market, who knows what is the future of your company? It is not possible. So they only took 70 servers from Amazon. But later point of time, they have seen there is a tremendous growth. Many people are interested in their product. So they increase the number of servers from 70 to 8,500. So if you go for in-house server, it is not practically possible. Cloud case, it is possible, right? You can expand up to 8,500. Later point of time, if they want to go to one server also, it is possible. Only you have to pay for 8,500 servers for the duration in which you have used. Right? That is another life story behind cloud. There is another company that is called Little Floppy Toys. So early days, that company, like early days when you go to a particular city, at that time bicycle, they are giving bicycle. You have to surrender your card. At that time, we don't have Aadhaar card. We have voter card. So you have to give voter card and you have to deposit 100 rupees. It is high amount. 100 rupees is high at that time. So let's say the cost of the rent of that particular bicycle is 10 rupees. So you have to go to a particular city. Generally, we go to our block or let's say state capital to do our work. Then once the work is over, again you have to come to that bicycle shop and you have to surrender that cycle. They will give you your epic card, okay, and return your money, right? The same thing done online by this company. This company is also a startup company. So initially, they don't have infrastructure, they don't have anything. So they have hired Google App Engine. They are live in the market within 1 week. So if you want your startup company, better to go for this one rather than purchasing your own infrastructure. Okay, this is the cloud architecture. There are no standardized architecture. There are many authors propose many type of architecture. So this architecture is called in market-oriented architecture. This architecture is proposed by Professor Kumar. So what he mentioned, you have user or broker. Like you want to book a flight ticket, but you don't know how to do. I want to book a flight ticket, but I don't know how to book a flight ticket. What I do? I go to agent. I specify the requirement to the agent. You aware of the system. So agent is a what? Intermediator between the user and the provider. Right? So user can directly interact with the cloud system, or broker can also interact with the cloud system on behalf of user. Right? So there is a service request examiner and admission control unit. What is service request examiner? Suppose in a particular server, I have 64 cores. Okay, I can give maximum 64 cores, but a user is requesting for 128 cores. Is it possible to provide? No. So the service request examiner will decline that particular request. Because once you agree, once you sign the service level agreement, later point of time you are not providing, that will lead to the violation cost. Right? Similarly, there is admission control. Every resources have some limitation, right? So you have to see that what is the maximum number of users can use that particular resources. So based on that, you can put some kind of threshold. You cannot exceed that particular threshold. Similarly, there are several units are there under the SLA resource allocator. Okay, there is a unit to monitor these virtual machines, which is hosted about the physical machine, and all these physical machines, you can say together, we can call it a data center. So data center is a bigger term. Inside that we have servers. Inside the server, we have virtual machines. We can create virtual machines based on the capacity of the physical machine. Okay, I told you there is another architecture that is called a service-oriented architecture, which is the backbone of cloud. Okay, like here you can see SP is the service provider, SC is the service consumer. How consumer will get a particular service? There should be some kind of registry. Right? You are searching in Google, you are getting some details, then you are locating a particular site. Right? In the similar case, here R is the registry. So service consumer will search and get a particular information about the provider, okay, from the registry. Then it can directly connect to the service provider and locate the particular resources, or ask for the resources, use the resources, or run its application. Okay, this I told you what is the difference between PJ as a service. Okay. Now I'll tell you a little bit about virtualization. So you can see we have computer hardware. Like I told you, in our system, we have two host operating system. If I am running a dual boot system, one is Windows, another is Linux. Both are host operating system. They are not dependent on each other, right? So the bottommost layer is always the hardware layer. You go to any computer architecture, you will find the bottommost layer is always the hardware layer, and topmost layer is always the software layer, right? So how to create multiple guest operating system? In order to create multiple guest operating system, you need a virtual machine monitor or manager, VMM, or a hypervisor. So hypervisor is creating the virtual machines. These are nothing but the virtual machines, which is a guest operating system. And on top of the hardware, you have a host operating system. There is two types of operating system. You can go for host operating system or you can go for guest operating system. Like I mentioned, you can go for Windows. Windows is your host operating system. On top of the Windows, you have hypervisor. Let's say that is VMware. And through VMware, you are creating a guest operating system. Let's say Mac operating system or any other operating system. So virtualization enables us to use the same piece of hardware by multiple machines. That's why resource utilization can be improved. Initially, all are dedicated machines. If you are using dedicated machines, definitely resource utilization is poor. But if the same machine, through virtualization technology, can serve multiple persons, or multiple clients, definitely the resource utilization is going to be improved. Okay, so this is also one of the example. You can see we have created different VMs, and maybe this VM is owned by a particular user, this VM is owned by another user, but they don't know they are using the same piece of hardware. Okay, the concept is the virtualization technology is that much powerful. Nobody is aware that they are using the same system, okay, same piece of the system or physical machine, but they are not aware of the thing that they are using the same, right? But security perspective, there is a attack called as a cross virtual machine attack. So if this virtual machine owner is little bit clever, so that owner can launch an attack to another virtual machine, which is called as a cross virtual machine attack. That is also possible. Okay, so obviously advantage of virtual machine is you may host in a particular physical machine. At the point of time, if you decided that this for physical machine is not having sufficient resources, you can migrate to another physical machines. So VM can be migrated from one physical machine to another physical machine. So based on your customer's requirement, you can do it. Okay, these are some of the advantages and disadvantages. Obviously, in-house server and cloud server, as I told you, there is also some drawbacks, right? With respect to the cloud perspective. What is the drawbacks? The first drawbacks is security. If you maintain your own infrastructure for HPC, definitely it is better, right? But if you are using a third party, then there is a chance of security leakage. For example, if you take a real life example, if you see US national security, so they have given enough freedom to their army that if they feel that any communication leads to some issue to their country, they can track it. Suppose you are sending an email from US, they feel that this email is having some suspicious information, they can track without any permission, right? Because everything is maintained by them. But assume that whatever email system you are using, it is hosted in any other country. Let's say US data is stored in Europe through another cloud service provider. So security wise, it is not possible to cross the boundary. So cloud phase, that is a major drawback, right? Cloud is another major drawback is that when the data is placed in a let's say a device where there is no mobility power. Suppose I am keeping my data in external hard disk, so it is in static state. When the data is moving, for example, I am sending an email, so the data is moving from my attachment is, let's say, you can also view once you get it. So the rule enforced to the data in static state and dynamic state, different rules are applied. So that is also one of the drawbacks of cloud. There is no standardized rule. Different countries are following different data policies, so it is really challenging. Another thing is you can see internet connection is always a problem in the cloud. If the internet is slow, you will get your service in very slow rate. Even if sometimes you are not getting service, in order to launch a particular virtual machine also it takes more time. So that is the major drawbacks of the cloud. Okay, so we'll see the rest part. I'll tell you about the parallel algorithm in my next lecture. So these are the things we have discussed. We have discussed what is the importance of computing, why there are different computing paradigms, why it is called as high performance cluster computing, high performance grid computing, high performance cloud computing, and what are the difference between these technologies. And we have seen a simple cloud computing architecture and the concept of virtualization. Okay, thank you. You can go through these papers by Prof. Asst. There is a nice book. If you want to start with OpenMP or MPI, refer this book. You can form a cluster and start your work. Okay, thank you everyone. If you have any question, you can ask.